Hey, in this video, we're going to build a high power op amp, a simple high power op amp out of power transistors and one resistor. It's based off of the same one that All About Circuits had. What they used for theirs was 2 and 3904 and other ones like that weren't power ones. They could only handle about, probably a little bit over half a watt of power. Very low current. Anyway, this one here should be able to handle more since it's power transistors, and in fact with it you can make it better by using a lesser resistor on the programming resistor. This is because these transistors here are high power ones. I think the reason why All About Circuits went with the low power ones because they're cheap, so you don't have to spend big bucks on it. Especially since the ones they're referring from Radio Shack, and anything from there usually is high priced. Not always, but sometimes it is. The resistors are. When you go to all electronics and you get like 10 of them, 10 quarter watt for like 65 cents, and Radio Shack has it for $1. Anyway, enough about that. The transistors we're going to use is complementary pair of this type right here. I found them on eBay. The cheapest one I found on eBay. It's a 2SC2581. That's the NPN one, and the PNP is a 2SA1106. This is audio power amplifier, which we're not using for, and a DC to DC converter, which we're not using it for. But anyway, this could probably work for any transistor you want. But the thing is, you gotta be careful with the program current. Another thing is, on this data sheet here, I don't see where it says anything about the base current, the maximum base current. What is it? The base can draw as many amps as it wants and it doesn't break? I don't think that's true. Maybe that's something to do with, I have no idea. Anyway, this data sheet here, I think they didn't put down the base current. Usually some of them have the base current in them. That represents the maximum base current. Now another thing is I found out with this op amp that we're going to build is that this is usually not going to happen unless you have power while you're wiring it. Is that I think one of the transistors when you don't use only using like one of the inputs plus or minus, and you don't use the other one, it draws a lot of current, I think, and the power supply turns off. This is what my power supply did, is it turned off, and I was like wondering, why is it turning off on me? Then I figured it out. It was because the inverting pin was floating. When it was floating, it shorted out the power supply, and it must have, the power supply turned off. Good thing that this power supply turns off. Otherwise this circuit might not work. Anyway, there's my circuit right there. Took me a while. It took me all day yesterday to find out what was going on wrong with it. It was this transistor here was wired backwards, and it still works though. I tested it out this morning, and I wired it as a voltage follower. Put 5 volts into it. I got 5 volts on the output. Then I tried a gain of 2. Put 5 volts in input. Got 10 volts on the output, which should be what it's supposed to be doing. Can you see that? I don't know if you can see that or not. Yeah, I can. For some reason, I'm outside in the sun, makes my screen look like it's not showing these parts up in there. I put electric tape around them. Got the electric tape there melted. So that's not the fault of the transistor, that's just electric tape. I put electric tape around these here transistors on there, so that if there's a copper foil behind it, it will not short out itself and then break the whole thing or stop or not work right. So the copper foil won't touch the tab on it, because I believe that tab's connected to collector, and we don't want that happening. There's VCC right there. That's where your positive goes into. The positive power supply right there goes into this foil here. Then down here is where your ground is. It says ground right there. This is your plus input. This is the plus input of the op amp. Then your minus input of op amp up here. And your out's right there between the two. So let's take a look at the data sheet. The data sheet says it can handle a collector base voltage of 200 volts. But the thing is, you're not going to be powering it by 200 volts. Or even up to that amount of range. And I don't know I doubt it's going to work that high. Because you'd have to have a high power resistor probably for your programming resistor right there. That one, there's a 390 ohm one. I didn't use 100K because the thing is, I was testing around in every circuit, and it seemed like that the lower resistor you go, the more current you get on your output, and it doesn't bother the input at all. Or does it? I don't know. Anyway, it doesn't really, because I measured between there and there with the meter, but that don't really tell anything. I have to measure with a current meter. There's two ways of doing that for current meter. You can use a resistor that converts it to a voltage in case your meter doesn't have a current measurement, which usually they all do, but this meter there doesn't. And so what you do to figure out the current, you put a 1 ohm resistor in series of it, and then put it in parallel with your with the meter, the voltmeter. The voltage drop of it will be times 1. The current will be times 1 on the voltage drop, so the voltage drop cost will be equal to the current. Making math simple. There's a lot of jumper wires here. I had to change some of these transistors with wired in the wrong places, but they work now. I'm gonna turn the thing on. I'm gonna first things first. We're gonna do it as a voltage follower. And why I got my computer power supply out here is because I want to have two different voltages. So one that's going into the op amp and one that's powering the op amp, to make sure that our op amp is actually amplifying. Because who knows, if you didn't do it that way, how are we going to tell if we're going to get a voltage out? I guess you could hook a pot to it, but the thing is, then you have to measure the pot, and then you have to do that. Let's just do something that has a fixed voltage. Okay, let's do it. Okay, first things first, I'm going to measure the voltage on the power going in to power up the op amp. It should come up to 12 volts for that. This ain't the input voltage I'm measuring from the inputs of the op amp. So I'm going to touch from there to there, and we get 12 volts, as you can see on the meter over there. Now if I measure from the 5 volts coming into the input, we should get 5. Yeah, we do. Now if I measure from the output, since the output is a voltage follower, we should get 5 volts from there too. And we do. The next thing is I'm going to put some resistors in. Those resistors will give it a gain of... First I'm going to talk about the circuit. I haven't showed you what the circuit is. You may know it if you're looking at it on All About Circuits, but if you're not, I'm going to show it to you. I printed it out just right here. This is the circuit here. Ignore the 100K or that transistor on that there in the pots. Then the pots are just for example to test the inputs. Put a voltage into the inputs. Let's adjust them. they're making current meters and something like that. Differential amplifier. I guess with constant current source, it probably helps the op-amp amplify and do what it's supposed to do. That constant current source probably doesn't have to be any kind of current you want. Of course, when they put it here, they put 100K there. And that one's off of 12 volts. And it's one off the power supply, a 12 volt power supply. This has two 6 volt batteries, but when you connect them in series, they add up. So they're 12. Now if we put a resistor here, right now it's connected to here to there, a short between there and there, which makes it a voltage follower. Now if we connect it from here for resistor there to there, and the resistor going to ground, we should get a gain of 2. Let's try that. I'm going to turn the power supply off so I don't break anything. Could have stopped the video, but that's okay. Almost got it. And wrapping the wire, wrapping the resistor lead around the transistor lead. And hopefully we don't break anything off here. We should get some alligator clips to put around it. I'll put this lead into the ground connector of this power supply. The lead into the floppy disk ground. Okay, I hooked the power supply back up. It's running, and we should be getting 12 volts on the power supply for the op amp. So if we get there, 11 volts to 12, close to 12, probably 11 point something. This meter could be off too. Anyway. Step to 5 for the input going into the input, the positive input of the amplifier, we get 5. Then for our output, we should get 12, not 12, 10. Wait, no, we get 10. That's a gain of 2 because 5 times 2 is 10. And this here shows you that this here can be a powerful op amp. I have no idea how much power to handle. It's probably simple, but it can probably be a little bit stronger than one of those chips ones. Because with those chips, the thing about those chips, the die is small, the silicon die, and it has to dissipate that heat from being drawing a lot of current to it. And that's what makes an op amp, op amp chip less powerful than this. It may not be as accurate or anything like that. It may not be able to handle that much of a load, but the thing is, if any of them break, you always figure out which one it is, or replace them all if you wanted to. Also, it could handle more current on the input, and also more voltage actually, depending on if you play around with that and put a higher power resistor in series with it, or even just put 100K there. and it put different higher voltage there. And this resistor here, it's a little warm, but not that much. I have no idea what wattage it is, but the thing is, it's supposed to be. If I did it in every circuit, which probably lied to me. It's probably half a watt would be of this type of resistor would go connected right there for the resistor program, the programming resistor. Well, that's it for now. So, thanks for watching if you like it. Okay, before we go, I decided to show you the current on the load it takes on the input, and also how it handles how this op-amp handles the output current. Anyway, right now it's hooked to it, and it is powered from it. Yep. Right now there's nothing on it. The negative point, if you see a negative 0.25 on the meter, that's just there because there's nothing there, and it's picking up floating. That's negative 0.2 milliamps or so, but that's not there. That's just floating. Remember that. Now we can measure from here. That's 12 volts, so that's 12 volts from the power supply. That's being powered by it. Now we're going to set the 5 volts, 5.03 or 04. We measure from there to there. We get, that. If I measure from the output, hang on. Yeah, we get the same thing. And that's just what with the resistor's not getting warm. Of course it will not, because it's only 5 volts. Anyway, it works out pretty well. Now this op-amp, I believe, cannot be a dual supply op-amp because base and the input go to a base of an NPN transistors on both sides, and I believe if then it will be, if we go negative, it'll go reverse bias and current won't flow. I'm not for sure. That's another downside for it. So it probably won't go good for my push-pull oscilloscope design, but it will go good if this is just a good thing to build if you want to build a powerful op-amp that can handle lots of current. And this here should be able to handle more better than the regular op-amp. So if you're just doing something basic, something that doesn't use like split supplies or something going negative, then this might be the good one for you to use. Because I believe if we go negative on it, it won't do nothing. It won't do what it's supposed to be doing. So I did try and compare it. You can't also, another thing, sense of that, you can't use it as a comparator either. So the only thing you can use it as is a op-amp, such as the inverting amplifier, non-inverting amplifier, or voltage follower. Basically, you might be able to use it as an oscillator. I don't know. You might be able to put resistors and capacitors in there to make an oscillator called what they call the wine bridge oscillator. Anyway, this is how it works. A 6 transistor, 6 powerful op-amp uses only 6 power transistors that are the same. They probably don't have to be the same, I don't think. But if you want your op-amp to act better and more accurate, you should use the same transistors on all of them and use the same complementary pair of them. It doesn't have to be the same model number. It just be the same. It has to be the same model number of the same complementary pair. So can't use NPN and PNP of a different model of two different model numbers of it. So, for example, you can't use a tip 4. It's fine at best to use a tip 3 to C with let's say 23904. So the two different deals are not completely paired to two different types of transistors at the same model number brand. Anyway, there you go. And it looks like I probably had my screen upside down. Anyway, this is how you build a powerful op amp. And we didn't have to use 100K. Only had to use something a lot less to get more power out of it. And the reason why I think all about circuits wanted to do 100K is because of the transistors we were using. It was because the transistors that they were using was not power transistors. They were simply a small signal one, which can only handle up to half a milliwatt, half a watt or so of power. Not that much current. So but by doing that, you make your op amp weaker because then on it you can't. It'll have an output less load. Because I did that before. I did it in the simulator, and then what happened is it gave me when I put a load on there of, let's say, like 1K or so, on the output, it gave me a way less voltage than it did with it floating, not floating, unloaded. And that's where it come to the problem where I probably didn't want to use that kind because of that purposes for that reason. So I decided to get these power transistors so we make it more powerful and see if we can do it the same way that they did it, but make it with power transistors on there so it can handle more power. And by doing that, we're able to use a small resistor for the programming resistor. And it hardly heats up at all. I don't actually feel hardly any heat on it. It's because when I did in the simulator, it was around like a little bit over a quarter watt. So if you probably do for 390 ohm resistor, makes you get half watt. And I wanted to go over 12 volts on the input side, on the power supply side, because it can probably break that resistor. Probably the transistors probably survive, may survive. Who knows? I just wish the data sheet would give us a base current rating. But I was looking through the data sheet, and they had at the bottom of the data sheet, it said, well, we're testing the current gain, the saturation voltage. It had IB, which must stand for the I as in current, and then base for the base, they had half amp. So maybe this can handle up to half amp on the base. Who knows? You know, it's not going to get that much really, because it's going to get more collected than it is on the base. Who knows? Anyway, this was a fun circuit to build. So, I hope you build it, and then you can have a powerful op amp that can power lots of stuff that a regular chip op amp couldn't do, because a chip op amp is basically a chip that's basically a tiny one with a tiny die in it, and it can't handle that much heat on it, because being such a small silicon die, it basically can't handle that much power, much heat on it, much current through it. The smaller it is, the less current it can handle. because I've seen these. It's just like those diodes. You get like a 5 amp one, it's bigger than a 1 amp one, and so on. So there's enough about that. This probably can work better than the op-amp, depending on which op-amp for whatever you want to do with it. Whether if it be a power supply or if it's going to be whether if it's going to be power supply or anything like that, big op-amp, you can probably use this better than, it just depends on whatever you use it for. This op-amp is probably good for if you use for voltage follower and non-inverting amplifier. Since I did a gain test on it and got a gain of 2 once I put 2 of those on there. But the thing is, op-amps are supposed to go negative. Maybe we'll go take a look at a data sheet of a real op-amp and see what the difference is on, because it should be able to go negative, and it should give us a negative voltage on the output, but it doesn't. It may if you use a dual supply. I have no idea. I haven't used a dual supply with it because I don't have no power supply that has capability of going dual supply. So that's it. I hope you enjoyed this video. Thanks for watching if you like it.